All right, so for your next big project, what if you didn't have to do it all yourself? I mean, what if you could just build a custom team of AI experts to handle all the heavy lifting? The research, the writing, the analysis, all of it. Well, that's exactly what we're diving into today with something called CrewAI. It's a framework that lets you do just that. Just think about it for a second. Let's say you need to research a super complex topic, then write a detailed report on it, and then build a presentation. That's at least 3 different skill sets right there. Instead of trying to get one single AI to juggle all of that, imagine assigning each one of those jobs to its own specialist. That's the whole idea behind collaborative AI. And it's not science fiction anymore. It's here.
And the framework that's making all this happen, it's called CrewAI. You can think of it as, well, an orchestrator for these autonomous AI agents. It gets them all working together like a perfectly oiled machine. So you're not just using a single tool anymore. Nope. You're more like the director of your own highly skilled digital workforce.
Okay, so how does this actually work? The biggest mental shift you have to make is to stop thinking like you're just writing a prompt for an AI. Instead, you need to start thinking like a manager who's building a team. Your first job is to scout and assemble the right talent for whatever project you're tackling. Yeah, this really isn't about trying to craft that one single perfect prompt. It's about handpicking a whole squad of digital specialists. Each one has its own unique skill, its own expertise, and when you put them together, you can tackle goals that are way, way too complex for any single AI to handle on its own. So, to get started building your own effective crew, you really only need to understand 4 core components. Let's break down these building blocks. The things that actually bring your digital team to life. All right, first step, you've got the agent. This is basically your individual team member. You give it a specific role, like senior research analyst, and you define its goal. And what's really cool is you can even give it a backstory. Something like an expert in emerging tech trends. That backstory actually shapes its entire personality and how it tackles the job. Okay, next, every single agent needs a task. This is the specific, actionable assignment you hand over to them. And having a really well-defined task is crucial because it keeps your agent focused and makes sure it knows exactly what success looks like. And then you put them all together to form the crew. This is where your individual agents actually become a team. The crew is what defines the whole workflow, who does what and in what order. It's the key to making sure they all work together to hit that final goal. And finally, we have what might be the most powerful part of this whole setup, the tools. Seriously, these things give your agents actual superpowers. They connect them to the outside world. A tool could be a live web search, or it could be an API to some database. This lets your agents work with real-time, up-to-the-minute data, not just the stuff they were trained on. So if you remember anything, remember this. The agent is the who, that's your specialist, and the task is the what. That's the job they have to do. Nailing that relationship between the who and the what, that's the absolute foundation of building a great crew.
Okay, enough with the theory. Let's see what this actually looks like in practice. We're going to build a really simple but surprisingly powerful crew with just 2 agents, a researcher and a writer. This should make all those abstract ideas feel way more concrete.
Building this crew is actually a straightforward 4-step process. Step 1, you define your agents. Step 2, you assign their tasks. 3, you assemble them into a crew. And then step 4, you just kick it off and let them get to work. So let's meet our 2-agent crew. On one side, we have our senior research analyst. Its whole job is to just dig deep and pull out the most important information. Then we have our content writer. Its job is to take all that raw info from the researcher and turn it into a nice, clean summary. See? 2 very different roles, but they're working on the same project. All right, so we kick things off by giving the researcher its first task. Go find the latest advancements in renewable energy. And just like that, using its web search tool, the agent is off to the races, scouring the web and gathering up all the relevant info it can find. And here is where the magic really happens. The writer's task isn't to just start from a blank page. No, its instructions are to take the output from the researcher and write a summary based on that. That's the whole point of this framework. One agent's finished work is literally the starting point for the next one. That's what true collaboration looks like. Okay, so A simple script like that is one thing. But what happens when you want to build a real application that actual human beings can use? Well, that means you've got to start thinking about design, both for the system itself and for the person who's actually going to be interacting with it. On the system side, a few things are absolutely key for success. You need super clear roles for your agents so they're not stepping on each other's toes. You need a rock-solid communication flow so that handoff from one agent to the next is clean. And you have to plan for scale, right? So your crew can take on bigger and bigger jobs without crashing. And then for the user, the design is just as critical. Of course, the interface needs to be easy to use. But the most important thing? Transparency. The user has to be able to understand how the crew got to its answer. If they can't see the process, they can't trust the result. An AI that's just a black box is pretty much useless. Oh, and it definitely needs to handle errors gracefully when, things inevitably go wrong. So where is all this headed? What does the future look like? Look, this is so much more than just a clever bit of code. It really represents a fundamental shift in how we can use AI to solve really, really complex problems. This is the future of AI collaboration. And there's a line from the source material that just nails it. It says that CrewAI offers a flexible and powerful framework for building sophisticated multi-agent systems, and that it promises even greater capabilities for creating intelligent and collaborative agent networks. It's moving us toward a future where we can build these incredible networks of AI specialists to go after some of our biggest challenges. Which, brings us right to the final big question. Now that you have an idea of how to build one, what problem would you solve with your own AI crew? The possibilities here are really only limited by our own imagination. And that's it for this explainer.
Talking about role playing, we're going to talking about agents that are able to focus, to use tools, to cooperate with each other. We're going to really dive into how guardrails are crucial to make agents work and how memory can make them so much better. We're going to talk about all the different ways that agents can collaborate, not only working sequentially and hierarchically, but also asynchronously. There's so many different options. So make sure that you stick around because we're going to build a lot of different crews throughout the different lessons.
A crew is a team of AI agents working together, each with their own defined roles. Don't worry if you don't know what this means yet. That's what this course is about.
We're going to start with an overview where we're going to build a simple research and write crew. But we're going to go all the way to build more complex ones, building a customer support crew, a customer outreach crew, an event planning agent system, and a financial analysis agent system. And then to wrap up, we're going to build our most complex crew yet. A crew that is going to be able to tailor-made your resume to any job posting out there, increasing your odds of getting an interview. So make sure to stick around for that because honestly, things are only going to get more interest from here out. So what we will build in this course? Let's look at this full stack engineering job posting. So you can see there's a bunch of interesting stuff in here. If you look close at the job description, you're going to notice that they're basically looking for a full stack developer. They want someone that nails both front and back end. And there is a bunch of actual criteria in there. They want you to be able to write APIs and to have experience with databases and all that. So this is what Noah's profile looks like. I'm not going to read over it, but let's highlight some of the stuff. You can see that Noah is trying to highlight how he's a good leader. So he mentioned how he has excelled in leading teams both remote and in an office. He mentioned some data science and machine learning, and he also mentions about deploying scalable AI solutions. That has nothing to do with the actual position that Noah wants to apply. But if you dig in there, you're going to notice that Noah also has some of those skills. You can see that it mentions there that it knows Ruby, Python, JavaScript, that it has been a software engineer for 18 years. So there is definitely enough things in there that kind of could explore and that make Noah qualify for this position. So how do we make sure that we help Noah to highlight all that in his resume so that he increases his odds of getting an actual interview for the position that he does wants to apply? Well, you can use agents to do it. In our case, by the end of this course, you're going to be able to put together a multi-agent system that does that. and that will do that by leveraging 4 different agents. It's going to have a tech job researcher, a personal profile for engineer, a resume strategist for engineers, and an engineering interviewer preparer. Together, those 4 agents will have a few tools that they're going to be able to use. From searching the internet all the way to do rag over resume, everything to kind of like help, in this case, your friend Noah, but yourself as well, to make sure that you're highlighting the right skills for the job. So this is what the new profile looks like. Let's compare both for a second. So in the second one, you can see that it was highlighting a lot of his leading experiences. But now in the second one, it's kind of like doubling down on the other skills that he has that better match the job that he's applying to. You can see that we mentioned JavaScript, Python, Ruby. We also mentioned UI, UX. You mentioned how he knows HTML and CSS. It's everything in there. So it's still the same profile and the same skill set, but framed in a way that now better allows them, or in this case allows Noah, to get the interview that he desires. So stick around if you want to build this, because by the end of it, you're going to be able to build not only these, but way more complex groups of multi-agents that are going to be able to do a bunch of automation for you. All right, so what is agentic automation? If you think about what automation used to be like before, it was something completely different. In the past, you would say, hey, I want to go from point A to point B. And you could write code to automate that. And then what happens is that as edge cases appears, you start to kind of make that a little more complex. You start to add a lot of conditions and ifs analysis there. Where like, well, if X, do C, if Z, do D, and you can see how these things can become quite complex, especially as you start adding more and more edge cases. So in the old days, whenever you're trying to do automations, what you end up with is this very complex code base with a lot of different conditions and edge cases, and you just can never cover it all. The beauty of agentic automations is that you don't need to draw the map. You can show the options. So it's fundamentally a new way to write software.
All right, so in regular applications, you have strong inputs. So you know exactly the data that is get into your application. You understand if that's a string, if that's an integer, if that's a float. You have a very clear understanding of that. And then you also have a very clear understanding on what is the mathematical operation that you might be doing with that, or any other heuristics. So you know if you're multiplying those numbers together, if you're interpolating their string, whatever is happening in there, you have fully control and understanding of what it is. And because of that, you also understand what is the output. You know if the output's going to be another float or another integer or another string, you can replicate it. And that's the beauty of regular engineering. But with these new AI applications, you have something else differently. You have a fuzzy input, meaning that you don't know what the user is input into your application. So you know that is a string because we're talking about an LLM, but you don't know if it's a string that represents tabular data, if it's a markdown, if it's a regular text, or if it's a math operation. And then the transformations are also fuzzy because they're LLMs. You don't know if the LLM will decide to transform this into a list or if it's write a full-blown paragraph. And because of that, you don't know exactly what the output will be because it can take different forms and shapes depending on the inputs and on the transformations. But that's the beauty of it. There's a place in the world right now where these fuzzy applications make way more sense than regular existing software applications. So that's the main reason why people like ChatGPT so much. If you think about ChatGPT, that's an AI application with fuzzy inputs. You don't know what your user is putting in the chat. It's also fuzzy transformations. You don't know what the LLM will do with that data. And it's also fuzzy outputs. You don't know what will be the final output, what will be the final response for that user input. And that's why people love it, because it's something they can relate to. If you think about the world as we have today, the world is a fuzzy place. So this is the beauty about AI applications, is that it's a valuable tool that has its merits and places where you want fuzzy applications and where you want strong typed applications, and each one has its merits and its place depending on the software that you're trying to build.
So let's look at some actual example here. Let's talk about data collection and analysis. And if you have been working in engineering for a while, you're probably familiar with it. There's leads data through a form, and those leads eventually go into your sales team that are going to try to make them into customers. So this is very usual for most of the businesses out there. And the way that these leads become customers is by prioritizing them. And there's a bunch of ways that companies use to do that. So you have your form and you capture information about this company through that form, and then goes through an automated process of classifying these leads, where you might look at some data points like, hey, is this company a big company? It has more than 10 employees. Is this company located in the US, or is this company located somewhere else? And depending on the answers for those questions, you might give a different score for these companies or treat them differently on your sales process. So this is regular data analysis and data collection. But it turns out that now that you can use multi-agent systems, you can go beyond that and you can go even further. So let's try something different. Let's think how a crew of AI agents could actually help us here and do something that's better than what we have been doing for the past few years. Let's add a crew of AI agents on the lead generation process. So what you can do now, instead of having all those ifs analysis, analyzing like specific data points for the companies, you could have these AI agents do research, go out there and do data collection. And this research can be searching Google, can be searching online, can be searched on an internal database or internal data set that you might have, whatever you want. Any place where you can find more information about these companies. Then you can also have these agents draw comparisons between these companies and companies that you already have in your data set, companies that you're already talking to, companies that turned out to be great customers. And then you can also have these AI agents do some scoring so they can actually score this company and making sure that this company has a score that you can actually prioritize and decide to who you're going to be sending it to. And then the final point is coming up with talking points. So not only doing the research, the comparison, the scoring, but also getting ahead and making sure that you know what are the topics that you should bring up when you go out and reach out to this customer and what that conversation should look like. And now you can take that and send that to your sales team. And you have a way better data set to work with than what you used to have before. So this is a great example on how regular automation can actually become way better by using agentic automation. All right, so we talked a lot about agents so far. We talked about a lot of different types of automations. But in the end of the day, what are agents? So let's talk about that for a second and step back. Options to tap into this. And what those LLMs do is predict the most likely next token. What happens is, if you try to chat with some of these LLMs, you're going to quickly realize that you're going to end up having like a regular prompting experience, similar to one you get with ChatGPT, where you kind of got to give feedback to it to make sure that through the interactions between you and this LLM, you get the results that you need. All right, so let's use ChatGPT for a second to see how exactly does that interaction works and why it could be better if we use it agents. So in this case, let's ask ChatGPT to help us create a marketing copy for CrewAI, a platform for building AI agents. So in here you can see that as regular, ChatGPT is going to start to write it down. What should be this copy? But it turns out to be too long. I don't necessarily want something this long. I want to make sure that it's smaller. It's something that I can maybe use on an Instagram post or whatever it might be. So now I get the chance to provide some feedback and say like, hey, this is too long. Let's summarize it. So once that you say that, you can see that it starts to get better. But the only reason why we can get not only GPT, but any LLM to get better results is through interaction, right? Is the iteration between the user and the LLM and the feedback that you provided to it that allow it to kind of correct its wrongs and get better results. So what you quickly realize here is that through the interactions, you can get better results, but you quickly become a blocker. You gotta be in there, kind of like answering these questions and interacting with it in order to get good results. So it's not freeing you up to do other work, it's just like enhancing you. But AI agents actually can break up that and allow you to do other work while allowing the LLM to operate autonomously. And the reason why we can do that is that because these LLMs were trained in so much text, and they understand text, they create a state where they kind of have cognition. And by that I mean that they can reasonably react. They can choose between A and B and left and right because they can put words together in a way that makes sense. So when you achieve that state, if you can have the LLM to kind of answer its own questions, then an agent is born. So the agent is born when you get this LLM to engage in an inner thinking process. Throughout, it asks questions and answer the same questions itself to the point that it can move on and get better by itself. So once that you get into that stage, it allows you to pass a task into this agent, and throughout this thinking process, this agent can then come up with a better answer. It's not the first answer that it would have given you, but it can then think through and optimize the answer up to the point that satisfies itself and then spits it out. But there is one thing missing here, a big component that makes this agent super powerful, and that's the ability to use tools. Other frameworks might call them skills or capabilities, but what they allow you to do is to your agent to interact with the external world. It allows your agent to do more, things that it doesn't necessarily would be able to do in itself. It could be calling an API. It could be posting something. It could be gathering a data point, whatever that might be. And this is a fully fledged agent. So let's talk real quick about what are multi-agent systems. So multi-agent systems grow on top of the agent behavior that we just described, where instead of having just one agent, you can now have multiple of them. So whenever you task an agent with something, this agent can also task another agent with another task. And in the end, you get one single final answer. But you might be wondering, what are the benefits of having that instead of having one single agent? Well, I will name a few, but we're gonna dig into that in further lessons. The first thing here is that you can have each agent be customized to do one single thing and do it well. You can have one agent, for example, being a researcher and another agent being a writer. So that allows your agent that is a researcher to focus on doing one thing and making sure that it finds all the sources, that check all the sources, that include all the sources. And your writer just use that in order to create the most amazing material ever. And the other good thing is that because you have multiple agents, you can have them run from different LLMs. So you can have your researcher running on Gamma 3 while your writer is running on GPT-4. You can also have your own fine-tuned version model powering some of those agents. So you can see how multi-agent systems can be so much more powerful than single agents, because it allows you to get very focused agents that will be able to achieve better results than if they're trying to do everything themselves, while also tapping into this ability to use different models from different sources. And we could keep going even one step further, where you can actually say, well, now I want multiple agents. But this is getting too meta. So let's step back for a second and let's first build our first multi-agent systems. For all the examples in this course, we're going to be using a super powerful framework. It's called CrewAI and it's open source. It's simple and it's designed for production use cases. It also offers a platform to bring your agents into production. But all the concepts that we're going to discuss here apply to all major frameworks out there. Before we jump into examples, let's talk about what is CrewAI. I want to take a solid moment to describe why all of the options that we have out there, we are using CrewAI in this course. CrewAI is a framework and a platform. And there's a few things that it offers that makes it super easy and super meaningful for us. The first thing is it breaks all these concepts into very simple structures. So it makes super simple for you to pick up on them. The second one is that it provides a pattern to put these systems together. So you don't need to think about how you're going to string all of this because it already kind of offers you an opinion on that. The third thing is that it provides many tools and skills that are ready to be used, and we are going to use them throughout the course. And the fourth one is that it gives you a module to build custom tools or agents. In some of our lessons, we're going to get to build some of those custom tools, and you're going to see how helpful that is. And also, as a final touch point, it also offers a platform for bringing these agents into production. So whatever you're building throughout this course, you're going to be able to also deploy in production through the CrewAI platform if you choose so. All right, so let's start looking at some of our initial building blocks. In this case, agents, tasks, and crews. We're going to be diving into those and building our first multi-agent system at the beginning of our next lesson. So if you like what you heard so far, if you got excited about any of the examples that you mentioned, I recommend you to stick around because things are only going to get more interested from here on. And there's so much they're going to be able to build with AI agents that I promise that they're going to be impressed by the end of this course. It's going to allow you to automate parts of your life, automate parts of your job, and honestly, unlock a lot of potential. So we're going to be talking more about how to actually build multiple agent systems. I honestly believe this is the future. It's going to be a key part of how businesses are going to be built and how engineers can drive an immense impact on your jobs and your career. We're going to start by looking at how we can build our first multi-agent system. And we're going to try to do things simple. I'm going to start by just copying some code in here, making sure that we don't get any warnings along the way. So we're going to start by importing the three main things from CrewAI. We're going to import agent, task, and crew. Those three classes are the main important part from CrewAI and how we are going to be building those multi-agent systems. Now that we have imported them, we got to choose what's going to be the LLM that's going to be the brain for all of our agents. So in CrewAI, you can choose your agents to be run from different LLMs, and by default, they all run from GPT-4. But in this case, let's make sure that they're running from GPT 3.5 Turbo. And you can do that by setting an environment variable called OpenAI_model_name. And in there, you can add the name of the model. You're going to see down the road that you can connect your agents to any LLMs out there that are not necessarily OpenAI. You can use local models, you can use any other major providers out there. So for this, let's make sure that we are using GPT 3.5. So let's start by creating our agents. Agents are the corner piece of how we're going to build the multi-agent systems. So for this use case, we're going to build three different agents. We're going to have a planner, a writer, and an editor. These three agents together are going to help us come up with amazing technical articles. So how do you create an agent? Well, it's pretty straightforward. You basically create an instance of the agent class. When creating that instance, there are a few attributes that you really care about, namely the role, the goal, and the backstory. So let's look into that. For our planner, we want to make sure that we set a role that matches what we want it to do. So we're going to keep it simple, and we're going to say it's a content planner. You're going to notice that in the following up lessons, we might do more complex roles and goals, but for this one, let's keep things simple. Now, let's set up a goal for this agent. The goal for this planner is basically plan engaging and factually accurate content on a given topic. You notice here how we are interpolating the variable topic within the goal. You can do that in the role, you can do that in the goal, and you can also do that in the backstory. And I'm going to show you how that plays a role on actually running these agents down the road. So now, let's set a backstory to this planner agent. So if you look at this, you might be wondering, why are we going to the trouble of setting up the role, the goal, and the backstory? One thing that you're going to learn in future lessons is the fact that agents perform better when role playing. In this case, you can see that the agent's playing as a content planner. So as much context as we can set in terms of like what kind of agent it is, the better, because it's going to conform to what we expect. So now I'm going to set up a couple other attributes, namely one that say that this agent is not allowed to delegate work to any other agent, and also making sure that it's verbose so we can see how this agent runs and its inner thoughts. Don't worry about those two attributes for now. We're going to get into them later. All right, so now that we have our planner here, we can create this agent. And there we go, we have our planner agent ready to go. Now let's move on and create our writer agent that's going to be responsible to actually write the content based on top of the research that the planner did. So in here you can see that we are doing a similar thing. This agent also has a role, also has a goal, and also has a backstory. And you can see interpolation happening on multiple fronts, but all the interpolation that is happening is around the same variable called topic. And we're going to see how that plays a role in here by the end of it. So let's create our writer agent. Now, let's create our final agent for this crew. And this agent is an editor. The editor is basically responsible to review the content, make sure that things are correctly formatted, that it's good, and it's ready to go. So let's go ahead and create that editor agent as well, to actually write the content based on top of the research that the planner did. So in here, you can see that we are doing a similar thing. This agent also has a role, also has a goal, and also has a backstory. And you can see interpolation happening on multiple fronts, but all the interpolation that is happening is around the same variable called topic. And we're going to see how that plays a role in here by the end of it. So let's create our writer agent. Now, let's create our final agent for this crew. And this agent is an editor. The editor is basically responsible to review the content, make sure that things are correctly formatted, that it's good, and it's ready to go. So let's go ahead and create that editor agent as well. With that done, we have 3 agents, but we have no tasks and nothing to guide them. So let's now create a task for each one of these agents. Create the task is as simple as creating the agent. You need to create an instance of the task class. So in here you can see that you can just type task, and
The task expects at least 3 attributes: the description, the expected output, and agent.
so the description is actually what do you expect the task to be? What do you expect the agent to do? So in this case, this is the plan task. So we expect our planner agent to look at the latest trends and look at the key players and making sure to create like a content or a research that we can use to actually write it down. The other argument that we expect in here is the expected output. And expected output here differs from the description because it kind of acts as a forcing function to force you to think exactly what you want to get out of the task, what you want this agent to produce as a final outcome. And here you can see that we're being very descriptive about it. We're saying that we want a comprehensive content plan with outline, audience analysis, SEO keywords, and resources. And then the final thing that we need to do is actually assign an agent to this task. So in this case, the agent that we're going to be assigning to this is our planner agent. And with that, we created our first task. Now, let's move on and create our write task. It's very similar, but again, different arguments, a different description, and a different expected output. And here you can see that the expected output for the write task is actually the actual blog post. And we want it to be written as Markdown, having multiple sections, and each section having between 2 or 3 paragraphs. So with that, we are ready to go because we have our 2 initial tasks. Now let's create our final task. This task is a little bit shorter because it's the edit task. This task is where the editor comes in and kind of proofread the blog post, make sure that the content is right, making sure that we have the paragraphs that we need, and that the thing is high quality. So we can also go ahead and create that task. So right now we have the agents and we have the tasks. We just need one way to mash those together. And that's where the third element of CrewAI comes in, and that is the crew. Crew basically puts together agents and tasks so they can operate as a unit. So in here you can see that we set 3 attributes. The first attribute is a list of the agents, the second one is a list of the tasks, and then we have a verbose mode that allows us to see how this crew is executing and look at some of its logs. One thing that I want to call out is that by default, a crew operates sequentially, meaning that one task is going to be executed after the next. Because of that, the order of the tasks when you create the crew, it's important, given that the output of one task is going to be sent as part of the input for the next. So you really want to make sure that you get that right. We're going to learn down the road that that's not always the case. And you can have a way finer control on what order you want those tasks to be executed if you want to send as part of the input for the next. So you really want to make sure that you get that right. We're going to learn down the road that that's not always the case. And you can have a way finer control on what order you want those tasks to be executed if you want tasks to be executed in parallel or if you want them to be executed hierarchically. It's all up to you. For this initial use case though, this is going to work great. So how do we actually get our multi-agent system run? One thing that I want to highlight here is this verbose setting being set to 2. Depending on how you're setting up your crew, you might want to be able to see a certain level of granular logs. So in this case, you can set your verbose node between 1 and 2, and that will define how much verbosity you're going to see on your logs. If you're going to see all the logs that are possible or just a subset of them. In this case, because we really want to see what is happening behind the scenes, we're going to set it the highest number possible, in this case number 2. So now we have our agents and we have our tasks. So how do we get it to run? How do we execute this multi-agent system? It's pretty straightforward. We use the crew.kickoff method. So you can do this by calling kickoff and then passing an input dictionary into the kickoff method. And this input will have all the variables that you interpolated throughout your tasks and agents. So this is where that topic thing comes into play. So you remember how we interpolated this topic variable throughout our agents when we first declared them up here. Well, now when we're kicking off our crew, we can actually set what is the word that we want to actually replace in all those different places. So now let's kick off our crew and see how that goes. So from the get-go, you can see that the content planner starts off and it's starting its first task that is prioritize the latest trend, key players, and noteworthy news on artificial intelligence because that's the topic that we set. So we can see here that it already did that, gave us an outline of what should be this article about, what should be the main topics that should include on it. So now we can see that our new agent kicks in, our content writer, and it uses the previous information, the research that was made, in order to put together a markdown blog post. So you can see in here how it's writing it all down for us. Now, the editor come in, proofreads and review and make sure that it aligns with our brand's voice and that it looks great. And by the end of it, we should have a full-fledged post. For doing that, I'm going to be using this markdown helper. So once that you do that, you can plot the markdown here and we can see what this article looks like. It's called The Rise of Artificial Intelligence, a transformative force in today's world. And you can see that it has subtopics and each subtopic has some nice content into it. All right, so now we have our agents doing the work for us and you can do it too. So I invite you to come in here and write the topic that you want your agents to write about, and you can execute this code and see they come alive and write this blog for you. So congratulations, this is your first multi-agent system and works great. Now, let's talk about other docs at some point. So let me go ahead and tell you, all the documentation that you find on CrewAI is actually written by a crew. So this is another great practical use case that showcases how multi-agent systems can help you with engineering work as well. Where we don't have anyone on our team writing docs anymore, because now we have a multi-agent system that does that for us. So I would definitely recommend you to think about all those different use cases that you could apply those multi-agent systems into. Let's do a quick recap about everything that we learned so far before we move on to the next lesson. So we now understand what are agents. They're the LLMs that can talk to itself. They have an inner thought process, and they can receive tasks and use tools in order to give way more complex answers that they would be able to do otherwise. We also learned that you can have multiple agents hooked up together so that one agent can pass tasks to another agent, and by doing that, you can have specific agents that are great in one single thing. We learned the three main pieces and the corner pieces of CrewAI. We learned about agents, tasks, and crews, and we now know how to put them together. But there are way more things that we learned through all this. First, we learned that agents perform better when role-playing. 2, you should focus on goals and expectations. Whenever you're creating your tasks and your agents, you need to make sure that you're setting up in a way they know what they're doing and they know what is expected of them. 3, one agent can do multiple tasks if you want to. In our use case, we had one agent for every task, but we could go beyond that. We also learned that tasks and agents should be granular. You can see how we focus each agent on one very specific thing. And we also know that tasks can be executed in different ways. We talked about tasks being executed in parallel, or sequentially, or hierarchically. And we are going to dive into all that in future lessons. And we also talked about how it's pretty easy to create multi-agent systems with CrewAI. So thank you so much for sticking around and learning more about multi-agent systems in this lesson. I'm looking forward to seeing you in the next one, where we're going to dive even deeper into how to build these agents and making sure that we're taking full advantage of them and their tools. The third one is tools, the fourth one is cooperation, the fifth one is guardrails, and the sixth one is memory. A lot of that is what makes good employees as well. You're probably good at your job because you're able to focus, because you're able to use the right tools, because you're able to cooperate with others, because there are certain guardrails, and you should have good memory. So let's dig into each one of those and talk about how these comes together to help this agent to be better. So let's start with role-playing. So the first thing is role-playing. Role-playing can make a huge difference on the responses that you're going to get from your agents. The ability for them to kind of just take the shape or form or a function for something else will have a direct impact on what kind of answers you're going to get and kind of what you're going for. So here's a quick example on how that plays a role even on a chat setting. But it plays an even bigger role once that you're doing on an actually agentic system where there's way more messages going on. But in here, I just asked ChatGPT to give me an analysis on the Tesla stock. And then I asked the same ChatGPT to do the analysis on the Tesla stock, but now I just set some context for each to role play into, saying that you are a FINRA approved financial analyst. So let's see the difference between those two answers. The first answer you can see that basically mentions about many factors. It kind of talks about financial performance. But the second one, you can see that is already digging straight into it, talking about NASDAQ, talking about the actual Tesla stock, and talking about EV manufacturing market. And you can see throughout the response that I'm going to spare you from seeing here, how that played a role on the response overall. So this is just a tiny example. I'm not saying that it's better or worse, but the role, the context that you set for your agent does have an impact on how it's going to respond. So my call out here is to be mindful as you're creating these agents to make sure that you're setting the appropriate roles, the appropriate goals, and the appropriate backstories, because that will play a role on the kind of results that you're going to get. But let me step back for a second, because I want to call out one thing. Realize how we use FINRA in our context setting. We could have just said that this chat is an actually financial analyst, and that's it. But by choosing the FINRA keyword, we're helping direct the LLM to give a certain type of answer. So in here you can see how Being careful and mindful about how you choose the role, the goal, and the backstory, and the keywords that go into that allows you to get better results out of it. We actually have customers and users using CrewAI worldwide. They're applying similar concepts to get better results out of their multiple agent systems. So I would be mindful about when you're setting the roles and the goals and the backstory to make sure to use keywords that will actually help you and will get you better results. All right, so we talk about role playing. Let's talk about focus. Focus is another big thing. And I'm not talking only about context windows. We know nowadays that LLMs have longer and longer context windows, and you can leverage that in order to produce amazing content and to also import a lot of content. But the one thing that becomes clear throughout many researches is that if you mix things up too much, doesn't matter if you're talking about too many tools or if you're talking about too much information or too much context, your models can lose important information and also open up opportunities for more hallucination. So another thing that makes agents great is their ability to be focused. And when I say that, I mean focused on the amount of the tools that they get, focus on the amount of content that they get sent, and also focus on what they're actually trying to achieve.
You shouldn't rely on one agent to do it all.
But instead, many agents that work better together. We have seen this in the industry. People that are using CrewAI out there have way better results when they are using multiple agents compared to when you're using one single agent throughout many different verticals. Focus. So what about tools? That's another common thing. People tend to try to give a lot of tools for their agents, and that can get confusing. You can overload your agents with too many tools, so they're going to have a hard time to choose a tool. They might end up not using a tool that they should, and you might end up having even bigger problems if you're using smaller models, because then they're going to get even more messy, not being able to distinguish what is the tool, what is the context, what they're trying to achieve. Because these smaller models are also less capable in general. So another rule of thumb that we tell for everyone that is using CrewAI out there is to choose the tools that you're going to give your agents. You want to make sure that you're providing them with the key tools to do the job that they need. The same way that you would do if you're hiring someone or if you're getting someone new on your team. All right. So we already know that agents now are great at role-playing, focus, and using tools. Let's talk about cooperation, because that also is another thing that makes a huge difference for agents. Ability to cooperate and to bounce ideas off each other makes a huge difference on producing better outcomes. The same way that when you're talking with ChatGPT, the process of having a conversation and giving it feedback helps it to produce better outcome. The ability for these agents, they're now role-playing to talk to each other and simulate that same chat behavior creates a better result. They can basically take feedback from each other, they can delegate tasks to each other, and by doing that, produce setup to being able to collaborate with each other. The next one is guardrails, and guardrails is so important. Because remember that we are now talking about AI applications, and we have talked about this in the past. AI applications imply on fuzzy inputs, fuzzy transformations, and fuzzy outputs. That means that you don't necessarily will get strong typed results. But that's okay because that's part of the application. That doesn't mean that you want hallucination though, or that you want your agents to get stuck on random loops or using the same tools repeatedly or taking too long to give an answer. That was actually a problem that we had early on the first versions of CrewAI, where agents would be stuck trying to use the same tool over and over again, especially if they're using open source small models. But we fixed that. Throughout many iterations, we implemented a series of guardrails that prevents your agent from derailing and nudge our agents to stay on track. And most of those are implemented on the framework level. So make sure to check whatever framework you're using. I can tell that CrewAI has a bunch of them, but it's also something that you want to consider when building custom tools, as we are going to discuss later in this course. But these guardrails are going to make sure to prevent hallucinations and to also make sure that you get reliable and consistent results throughout your multi-agent systems. All right, now there's just one last thing to talk about: memory. Memory can make a huge, immense difference on your agents. If anything, it can make more difference than all the other things combined. Memory is the ability for your agent to remember what it has done. And not only that, but to use that to inform new decisions and new executions. The ability to recollect what they did in the past, learn from it, and apply that knowledge into future execution. Some framework will offer different types of memory and different types of implementations for it. In the case of CrewAI, because we are using this, our agents will get 3 types of memory for free out of the box: long-term memory, short-term memory, and entity memory. Short-term memory is a memory that lives only during the crew execution. Every time that you run a crew and you kick it off, it starts from the blank. This memory is useful because as different agents try to accomplish different tasks, they store different things that they learn in this memory. And this memory is shared across all the agents, meaning that an agent number 2 or an agent number 3 can tap into learnings from agent number 1. So the short-term memory is something that helps to share context during the crew execution so that you get better outcomes. Now let's talk about long-term memory. As the name suggests, long-term memory lives even after the crew finishes. So that memory is stored in a database locally, and that allows your agents to learn from previous executions. So every time that your agent completes a task, it self-critiques itself to learn what it could have done better, or what are the things that should be in there that are not. And it stores that information so that it can tap back into that when it's running once again, and then use this knowledge to produce better and more reliable outcomes. The entity memory plays a role in here as well, as it's also short-lived, so it's only lived during the execution. It stores what are the subjects that are being discussed. So if your agent's trying to learn something about a specific company, it might store that company as an entity and its understanding of this company in this database as well. So together, entity, short, and long-term memory plays a role on helping our agents to get more reliable outcomes. If your agents didn't have a memory, you would probably get slightly different results every time that you run them. But because they do, you not only get more reliable ones, but you also get increasingly better ones because they learn from their mistakes. I'm super excited about this one because we're going to be talking about how to use multi-agents for customer support automation. And that is such a big use case. If you think about customer support, it feels like a no-brainer to have AI agents to help our customers to have just a better service in being able to tap into all of the docs, knowledges, and help center in order to provide very meaningful answers to these people that are trying to use customer support. Let's try to do some code and see how that works. Again, I'm going to start just doing some boilerplate code to make sure that warnings doesn't get in the way. And I'm also going to import the same components that we learned on the last lesson, where we bring the agent, the task, and the crew classes into this. For this example, we're going to be using GPT 3.5 Turbo once again. So let's go ahead and set that environment variable. All right. So now let's dive into agents and how we can make them great, how we can bring everything that we learned into the slides into actually creating these agents. So we know that agents are impacted by the role-playing, the focus, the cooperation, the tools, the guardrails, and the memories. All right, so for this use case, we are going to be building a support multi-agent system. The goal is going to be to help supporting customers that might have inquiries about a product. So the first agent that we are going to create is a support agent. So this support agent should be straightforward. You can see here that the role is a senior support representative. You can see how we use the keyword senior here, again, to imply that we expect answers that are a little bit more polished than what you would mostly get out of the box. For the goal, we also mentioned that the goal is to be super friendly and helpful. So that will also play a piece on every step on the process. And for the backstory, we tell this agent works at CrewAI, and they're helping a specific customer. You can see the interpolation happening here again, trying to answer a specific question. But that agent alone is not going to help us. We're going to need another agent as well. So this other agent is going to be a support quality assurance agent. So let me copy that and paste it here. So this agent exists to help the support agent by fact-checking everything that it says and making sure that it's the best response possible for this customer. All right, so now we have both our support agent and our support QA agent. So far, we can see how we're doing very focused approach here, where we are prompting the agents to be very much getting into character of their role. You can also see how one agent is not allowed to do any delegation because we're setting allow delegation to false. But we're not doing that for the support quality assurance agent. That means that this agent can delegate work back to the original support agent if it decides to. So this is an important trait for your QA agents. Make sure that if they find something that doesn't feel right, they don't necessarily need to fix themselves, but they can actually delegate it back to another agent that might be better suited to do it, because either has like the right set of tools or the right set of backstory, goals, and roles. So you might be wondering, when exactly an agent decides that's reasonable to delegate work to another or to ask questions to another? And this is some of the differences between regular engineering and AI engineering. AI applications, again, they have fuzzy inputs, fuzzy transformations, and fuzzy outputs, meaning that they don't necessarily follow the same pattern all the time. So in this case, we are relying on the brains, the LLMs, to make a conscious, reasonable call on when to delegate and when not to delegate. All that goes back to the fact that these models have a level of cognition because they understand language. So depending on the customer inquiry, they might understand that it's worth delegating and to do more research. But if it's a more simple inquiry that demands a simpler answer, you might not want to delegate it back. So this is not something that you necessarily will have full control of, but you don't really want to, right? That's the magic of AI apps, is the something that you necessarily will have full control of, but you don't really want to, right? That's the magic of AI apps, is the ability for these apps to react on runtime on how they're going to handle with the information that they're being handled at. So make sure to keep that in mind, that allowing an agent to delegate work and ask questions don't necessarily imply that it's going to do it every time, but that instead we'll give it the option to do so if it chooses to. So this is one way on how you can get your agents to collaborate together, and a great example on how collaboration helps with better quality responses. So this is a very common pattern that we see throughout many users on CrewAI. Usually, having a final agent that is kind of like a quality assurance agent helps a lot and go a long way, because they can do a final pass on whatever you want to do, writing a blog post, entering a customer, whatever it might be. So I do recommend you considering adding a QA agent of sorts into whatever multi-agent systems that you do, and that does tends to perform better than regular agents without it. So far, this is a great example of role-playing, focus, and cooperation. All right, so now let's move on and talk about tools, guardrails, and memory. For that, we're going to be using CrewAI tools. So CrewAI also has a tools package with a set of tools that you can use. They have simple ones like the ones that allow you to search the internet, to more complex ones that allow you to do full RAG over GitHub if you want to, or websites. There's many that you can explore, but we're going to stick with some of the simpler ones in here. We're going to use the Serper Dev tool, we're going to use the Scrape Website tool, and we're going to use the Website Search tool. SerperDev2 basically integrates with Serper. It's an external service that allows you to search Google. Scrape Website is a simple scraper that allows your agent to access a given URL and extract the contents of that. And the website search tool is actually doing RAG over a website. If you don't know what RAG means, it's doing a semantic search over the content of that website. So in here, you can see that we are importing the CrewAI tools package and then these three classes from it. So let's go ahead and run that. So this is a great place where you can also think about other tools. So we're not going to talk about creating your custom tools right now, but this is a place where you could bring like tools that load customer data, that tap into previous conversations, or that load data from a CRM, checking existing bugs, feature requests, or ongoing tickets. All useful tools that would help these agents to provide better answers to the customer inquiry. So you can see here on how you should be thinking about what tools you should provide to your agents in order for them to provide meaningful responses. All right, so for every CrewAI tool, there's a few different ways that you can use it. Let's say that we want to use the SerperDev tool. This is the only thing that we would need to do. Create an instance of the SerperDev tool, and we assign that into a variable, and we should be able to use that. We can also do the same thing for the Scrape Website tool, where we create an instance of that, and now we have that too, and we can assign that to an agent or to a task. But another interesting feature of CrewAI is that you can also be more specific about how you want these tools to be used. So let's say that in this case, I want my agents to only search the CrewAI docs. So I don't want it to be able to scrape any website out there, but I wanted to scrape specifically one single page of our documentation. So I can actually do it. When I instantiate this Scrape Website tool, I can set an optional argument called website URL. And in that URL, I can set a specific URL that I want this to be able to scrape. So here is a great use case where you can see that you use the same tool, but one tool would allow your agent to scrape any URL that it becomes aware of, as long as the agent deems that scraping that URL would be beneficial. The second one allows your agent only to scrape one certain URL and not every URL that it finds. So you can see how this can be very versatile as you're building your agents. Would allow your agent to scrape any URL that it becomes aware of, as long as the agent deems that scraping that URL would be beneficial. The second one allows your agent only to scrape one certain URL and not every URL that it finds. So you can see how this can be very versatile as you're building your agents. For now, let's focus only on our docs search tool and see what our agents can do with that. All right, so now we already understand how we can bring tools into this. So how we assign those tools, how we give our agents those tools. There are basically two different ways that you can give your agent tools. You can give them at the agent level, or you can give them at the task level. What that means is that if you give your agent a tool, that tool belongs to the agent.
It can potentially use that tool for any task that it performs.
But if you give it to the task, that means that the agent will only use that tool when performing that specific task. So an easier way to put this is that task tools override the agent tools. So an agent might have 10 tools at his disposal, but when performing a given task, if that task only says that it has 3 tools at its disposal, then the agent will only use those 3 tools. So let's start by creating our first task. The first task that we are going to do is the inquiry resolution task. So in here, you can see that we're playing even more with the interpolation, where we're saying, hey, this customer just reached out with a super important ask. Here's the inquiry. The person that works at this customer is the one that reached out. Make sure to use everything that you know to provide the best support possible. You must strive to provide a complete answer. So you can see here how this looks like more regular prompting, but we're using that interpolation in a lot of different ways. And then again, we come with an expected output with very clear instructions on what we want to get back from this agent. And we provide the tools in here. So the tools is just an argument within the task, and it's an array that includes all the tools that you want to be available when the agent performs this task. In this case, it's only one tool, our docs scrape tool. So let's go ahead and create this task. Now, we're going to create our new task. That is going to be the task that the QA agent will use in order to review the work that the support agent did. So it's a similar task that doesn't use interpolation, but rechecks what the agent viewed. You can see that in this case, this task has no tools at its disposal, meaning that the QA agent, when performing this task, won't be able to look at our docs. It's purely assessing what is the actual response that the support agent wrote. All right, so now we got our two tasks that were created. That's great. So let's put our crew together. Create our crew, and in this crew, we're going to bring our two agents, the support agent and the support quality assurance agent, and also the two tasks, the inquiry resolution and the quality assurance review task. And also, you notice that we're using memory for this one. So using memory with CrewAI, it's super easy. You don't have to worry about it. You don't have to think about it too much. You can set this one single attribute on your crew, and that enables all those memories for you. The short-term memory, the long-term memory, and the entity memory. So you don't have to configure anything other than set this one flag, and everything works out the box. So let's now focus on executing this crew so that we can actually get some results from it. In order to execute this crew, we need to pass inputs to it. We need to override all those interpolations that we did in the tasks and in the agent's definitions. So in this case, we had three main interpolation variables. We had the customer, the person, and the inquiry. Here, we're saying that the customer is deep learning AI, the person that is asking the question is Andrew, and the inquiry is it needs help setting up a crew and kicking it off. And we want to make sure that it's using memory to set up that crew. Can the agents provide some guidance and actually help Andrew with that? Let's see how our agents do in trying to help Andrew. So from the get-go, you can see that our senior support representative is kind of like kicking things off and kicking it off. And we want to make sure that it's using memory to set up that crew. Can the agents provide some guidance and actually help Andrew with that? Let's see how our agents do in trying to help Andrew. So from the get-go, you can see that our senior support representative is kind of like kicking things off, starting to look into the issue that Andrew brought up. You can see here the interpolation play its part, where deep learning AI is kind of like popping up in the task. So we can see that the agent now decides to read a website content, and it's actually looking into the documentation that we provided it with. So with the access to that documentation, it's learning everything about CrewAI and how to create these agents, how to create the crews, and how to kick it off. And then it comes up with an answer. In this answer, you can see that it's super polite. It says, hey, dear Andrew, thank you for reaching out for assistance. And then goes on into explaining how to install both CrewAI, CrewAI tools, how to create the agents, and then how to create the crew with the memory and everything within it. You can see that once that this work is done, we now have our next agent, the support QA specialist, kicks off to make sure that this is the best answer possible. So in here, you can see that it didn't really like some of the responses, so it decides to delegate the work back to the coworker, asks us to review and revise the response to ensure that it's comprehensive, accurate, and friendly. So now it rewrites, being a little bit more friendly on the response. You can see that it's more direct. It's basically saying like, this is how you set our crew, and this is how you add memory. because those were the specific topics that Andrew originally asked it for. So you can see here how the answer looks way better, and now we should be able to get back to Andrew with that. You can see that the agent still is not super fan of that, so he decides to ask a question to the coworker again to confirm if those are all the steps to create a crew and to add memory, and if there's nothing that is missing in there. So this agent kind of gives like more information around anything that might be helpful, and after that it puts together a final answer. And the final answer says, "Hello Deep Learning AI, thank you for reaching out for assistance in setting up a crew and adding memory. I have reviewed the response draft and made some revisions to ensure clarity and completeness. Below is the steps that you need to follow." And then goes on like with the steps to create the crew and to add memory to that. So now this is something that we could actually send out back to Andrew. Make sure that it has all the information that it needs. And there we go. We created a new multi-agent system that is now capable of collaborated. So two agents are delegating and asking questions to each other. They are using memory, so they remember what they are doing as they are doing, and they are very much going into their roles by using role playing. So you can see all those elements that we talked about in our slides being played at here at real time. So let's go back at our slides real quick. Creating agents that are the best they could be. So I have a mental framework that I like to share, and I think will be super helpful to you. So the framework is to think as a manager. Honestly, there is a very high correlation between being a good manager and being able to create great multi-agent systems, because managers are conditionally to think about what is the goal and what is the process. So whenever you're creating your multiple agents crews or your multiple agent systems, I would say think about exactly what is the goal that you're trying to accomplish, and then what is the process that you're trying them to follow. If you think like that, you're gonna then start to thinking about what are the people I would hire to get this job done. So that's the thing you want to be asking yourself. If I had to hire people to do this, what would be the people that I would hire? So once that you get that answer, you're going to know what agents you need to build. And more than that, you're going to know exactly what should be their roles, what should be their backstories, what should be their goals, because you know who would you want to be working on these things. So let's talk about some examples. These are some examples that are not necessarily the best. Like if you want to create, for example, a use case related to HR, you don't want necessarily only a researcher, you want an HR specialist. And that plays across all the examples that we're going to see throughout this course. So better examples would be an HR research specialist instead of just a researcher, or a senior copywriter instead of just a writer, or a FINHA approved analyst instead of a financial analyst. So I would recommend you to really think about what are the keywords, what are the actual people that you would hire to do this, and then once that you have those people in mind, think about what would be their goals, what would be their roles, what would be their backstories. Those are the agents that you want to build. And in the community that uses CrewAI, we notice that the people that get the best results are the people that really think about agents in that way. They think about what would be the people that they would hire to do this job for them. All right, let's do a quick recap to see everything that we learned this lesson. First thing, we learned that agents do a better job if they have a few things. They are doing role-playing, they have focus, they have the appropriate tools, they're allowed to cooperate, they have some guardrails, and they also can leverage memory. All right, we also learned some other stuff. We learned that agents are able to self-improve by using memory. We also learned that CrewAI prevents your agents to get into rabbit holes by making sure to steer them in the right ways. We also learned that the agents will always attempt to get you an answer. And we also learned that smaller tasks and focused agents perform better than bigger tasks in agents that have too much on their hands. Also, focus tools plays a huge role on that. And we're going to be talking about tools next. So thank you so much for sticking around for this lesson. Honestly, it has been incredible to go over this with you. I hope you're having as much fun as I am. And stick around for the next one. It's going to be super fun. We're going to start talking about tools. And guess what? Tools is what unlocks a lot of the fun use cases. So I see you in the next lesson. To our new lesson, we are talking about tools. Tools are such an important part of CrewAI and of any multiple agent system out there. Tools are what allow your agents to communicate with the external world, to get out of their bubble of just chatting with themselves and actually perform actions, have an actual impact on your flows, on your systems, on your users, and on your company. So it's a super key part that makes agents great. So what makes a great tool? What makes a tool set itself apart from another? Well, there's at least 3 things that we found from the many users that use CrewAI that set a tool apart from each other. The tools that are versatile, the tools that are fault tolerant, and the tools that implement caching. We're going to talk about each of those topics right now. So what it means for a tool to be versatile? Well, first thing, a tool needs to be able to accept different kind of requests. The tool is the connection between the AI apps that have fuzzy inputs with the external world that have strong typed inputs. So your tool needs to be versatile enough so that it can handle the different things that an LLM might throw at them. So CrewAI supports converting these arguments into the correct types, and they can handle the different nuances coming out of your agent. But if you're building it to yourself, you want to be sure that whatever the LLM send your way, you want to treat it properly, you want to convert it to the appropriate type so that you can actually use it. So one big piece of making a great tool is making sure that it's versatile. It can handle different types of inputs. The second thing is being fault tolerant. This is the thing that a lot of people that were using AI agents early on realize, that as your agent passes information to your tools, things might break and you're going to get exceptions. If you get exceptions out of nowhere and you don't treat them right, you stop your crew right there because it stops the execution. And you don't want to do that. So you want to make sure that your tools can fail gracefully. So in case something goes wrong, they can kind of self-heal. CrewAI actually implements that by default for you. So even if an exception happens when running a tool, instead of stopping the execution, it sends that message back to the agent. So the agent can take action on that. Maybe it's the input. Maybe the agent should have sent a different kind of input. Maybe the agent missed on a required argument. Or maybe there's just another problem. But the important thing is that your tools should be self-healing and should fail gracefully in a way that doesn't stop your agent execution. This is something that we see a lot out there. When you deploy these agents at scale, especially in enterprise companies, you're going to have agents dealing with all sorts of documents and all sorts of sources for files and information. So you want to make sure that the tools are able to handle all that and able to handle when seeing something that they don't expect. We actually have seen this in some of our biggest users where they're analyzing huge amounts of financial documents, and sometimes the numbers might not be the easiest ones to read, or the text might not be the easiest one to parse. That said, you want to make sure that your tools kind of work around that a little bit. All right, so you have a tool that is versatile and you have a tool that is fault tolerant. That means that you got a lot of that job done. What about caching? Caching is key to make these tools worth it and usable in the real world. Whenever you have a tool, most of the times, that tool is used to communicate with the web. So it's going to call different APIs. It's going to call different services. Sometimes it's going to be internal services. Others are going to be external services. And whenever that call happens, you want to make sure that you're being mindful about taking the time to do the request and also not doing the request unless necessary. So having a caching layer
that prevents unnecessary requests
from happening is crucial to make sure that you're building optimal crews. So you want to make sure that you have not only cache, but you have a smart cache. So in CrewAI, we offer cross-agent caching. What that means is that if one agent tries to use a tool with a given set of different agents, they're going to actually use a cache layer. So the second time they try to use a tool, they're not going to do that API call. And that makes a lot of difference. That prevents unnecessary requests, that prevents hitting rate limits, unnecessary consumptions, and also saving execution time, making sure that your crews and your multiple agent systems run faster. So caching is super important when you're building crews that you need to run at scale. What are some examples of tools? Well, there's a bunch that we can talk about. There's the simple ones like search the internet or scrape a website, tools that we actually have used ourselves. But it goes beyond that. You also can connect to a database, you can call an API, you can send a notification, and many, many more. So you can see here how tools are such a cornerstone, and that is the case for all the frameworks out there, including CrewAI. So in CrewAI, tools are such an important piece that Crew offers a bunch of them out of the gate that you can use. So whenever you have the time in the future when building your own tools, make sure to check CrewAI's documentation, where you're going to find all the documentation for all the existing tools in there. Also, another thing that's important to highlight is that CrewAI support all LangChain tools. So LangChain also offer a huge set of existing tools, and you can use them right away with your crews using CrewAI. So just another thing to highlight. But enough of that. Let's jump into some code and see how we can build some tools together. For that, you're good to go and ready to get started. All right, so now that you imported the agent, the task, and the crew class, we can set up what model we're going to be using. So for this one, we're going to be using GPT-4. So you have been using GPT 3.5 up to this point, but we're moving to 4 now because we're going to be handling with more data. So you want to make sure that you have that extra context window to handle all the information that we're going to be sending to these agents. So let me just copy this and paste it here. Another thing that you're going to notice is that we're using Serper API here. So Serper is basically an API that allows you to search Google, and you're going to be provided with a key that you can use. But you can also go into their website and sign up, and they offer free credits. But honestly, there's a lot of other like search tools that we could use as well. We just choose to use Serper in this example. So let's go ahead and just execute that. All right. So now we're ready to dive into tools. We basically want to make sure that we use some of the CrewAI tools, and we also want to make sure that we create a simple custom tool to show you how that looks. So let's go ahead and start creating our agents. We're going to have 2 agents for this. The first one is going to be a sales rep agent because we're going to be doing a sales use case this time. The sales rep has one goal, and that is identify high-value leads that match our ideal customer profile. People like to call that ICP. And sales is a big use case for multi-agent systems, so probably you're going to see a lot of that around the internet as well. You can see that in the backstory, we set some context around the fact that the sales agent work at CrewAI and some of the mission around it and everything. You're also going to notice that this agent is not allowed to delegate any work or ask any questions. It's just supposed to do what it's told. We're also going to create a new agent, and that's going to be a lead sales rep agent. So let's execute this and then create our new one. So this lead sales rep agent, you're going to see that it builds on top of our previous one. It has a different goal. This goal is kind of find the actual personalized content and build a personalized communication with this lead that we're going to be working on. So the idea of the Crew in the end of the day is giving a lead, find out a way to communicate with them that helps them to get interest on CrewAI. So let's see how that's going to play out. So let's first execute this agent. All right. So now we have those 2 agents created. Now it's time for us to look into the tools that we're going to use. we're going to be using the CrewAI tools package again. So you can go ahead and type that out and import those tools. You're going to see that we're using 3 tools this time. We're using a directory read tool, we're using a file read tool, and we're using a Serper dev tool. So the directory read tool will allow your agent to read any directory that it wants. Or again, you can kind of like confine its options by saying a specific directory that you want it to run. Then the file read tool, the same thing. And the SERP tool, we already talked about that in another lesson. It allows you to search the internet. So let's go ahead and instantiate those 3 tools. So you can create a directory read tool, the file read tool, and the search tool. And the one thing that you're going to notice is that on the directory read tool, we're specifying that we want it to be able to read only this local instructions directory. So in this directory, there are a series of instructions as markdown files on how to handle companies from different sizes. So you're going to have big companies, small companies, and medium companies, instructions on how to handle them. And we're letting our agents being able to read these files by setting up this tool that allow them to actually look at that folder. So as you can see, we now have 3 tools that we're using here: our directory read tool, our file read tool, and our search tool. And you can see they're like all similar, but the directory read tool actually is passing one attribute called directory. This attribute is forcing this tool to only allow the agent to read this one single directory. In this case, is a local directory called instructions. So this local directory basically holds a set of instructions on how to handle some of those customers, if it's a big customer or a small customer or whatever it might be. Let's look at those files real quick. So here you can see instructions on how to handle some of those customers, if it's a big customer or a small customer or whatever it might be. Let's look at those files real quick. So here you can see that there are 3 files inside that directory. A file that has a set of instructions to how to handle small business, on how to handle tech startups, and on how to handle like more enterprise deals. And you can see here there's like a specific template, there's key strategic points to address, there's introduction. So everything that our agent might need in order to actually engage with like a specific company. So now that we have our tools here, we can create a custom tool just to see what that would look like. So every framework out there is going to give you a pattern to create a custom tool. And CrewAI is no different. It offers a couple different ways that you can use to create a custom tool. So in this case, the way that we are going to be using is by inheriting from a class inside CrewAI. We can import this class. It's called base tool. And now that we imported it, we can create our own class that's going to be our tool that inherits from that. So in this case, our class will be called sentiment analysis tool. So you can envision that this tool would do some sort of sentiment analysis, but this could be anything. This could be an external API call or whatever you want. But in this case, we're just going to fake it a little bit to make sure that we build a custom tool and we learn how to do it. So one thing that every tool needs to have in CrewAI is a name and a description. So in here, we are setting the name of this tool to sentiment analysis tool, and the description tells the agent when it should use this tool and what is its purpose. So in here, we're saying that it analyzes the sentiment of the text. And then in order to actually implement the tool, all you gotta do is create this run function inside that class. So as long as you have this underscore run function in there, you can add any code that you want. So in here is where you would call an API, or where you would take an action, or send an email, or anything you wish your tool to do. In this case, we're keeping it very simple because it's just an example, and we're just returning the word positive. So this is a sentiment analysis tool that always returns that the sentiment is positive. So now that we create this tool, we can actually instantiate it so that we can use it. the same way that we did with the tools above, with the directory, the file, and the search tool. So you can go ahead and just do that. And now you have the sentiment analysis tool, and you can pass that to your agents and tasks. So now that we instantiate our tools, let's create our tasks and assign them properly. Here we're going to be able to see how we can focus in specific and clear goals on what we want to achieve by using these tools. So the first task that we're going to create is a lead profiling task. So the lead profiling task basically conducts an analysis on a given lead in order to understand its sector, how big it is, information that might be useful for us to engage with this potential customer. So in here you can see that we are providing it with a set of tools, our directory read tool, our file read tool, and our search tool. So with these tools, this agent, when performing this task, are going to be able to look at those instruction files that we saw before, read them, and then using the SERPer API, search the internet for more information about this lead. So let's go ahead and create this task. Now we're going to need a new task. This new task is going to help with creating a personalized message to outreach for this specific lead. So I can paste it in here, and you're going to see that this task has a different set of tools. It doesn't need to read the directory any longer because by now it already knows if this is a big or a small company and already has done some research on them. This task is focused specifically on doing a sentiment analysis and doing any further search that might be necessary in order to make sure that we talk with this customer in an appropriate manner. So you can go ahead and also create this. Okay, so now that we created the two tasks, you can create your crew. The crew is pretty straightforward, the same way that we have been doing so far. We pass in the agents, we pass in the tasks. You can set the verbose mode to 2 and in an appropriate manner. So you can go ahead and also create this. Okay, so now that we created the two tasks, you can create your crew. The crew is pretty straightforward, the same way that we have been doing so far. We pass in the agents, we pass in the tasks. You can set the verbose mode to 2, and you also set the memory so that this crew is using the memory functionality and features. You don't necessarily need to if you don't need, but I think it might be a good use case. So let's go ahead and run this. Now you can kick off this crew, and kicking it off should be pretty straightforward. So in this case, we're passing a set of inputs. Remember that these inputs are going to be interpolated in any place that we use them, both in the tasks and in the agents. So these inputs are going to be used into any place in the tasks descriptions or the agents definitions. Anywhere where we try to interpolate these variables, we can now pass their values in here. So in this case, we're simulating that the lead name is deep learning and AI. In their industry is online learning platform. The key decision maker is Andrew, and he is the CEO of the company. And the basic milestone that they have is a product launch. So we can go ahead now and kick off this crew. So everything starts with our sales representative, and it's going to start by conducting this in-depth analysis of the deep learning AI company and basically trying to learn more about it. So you can see here that it started by searching the internet, trying to understand more about deep learning AI. So in here, you can see all the search results that it got from Google. And if you scroll further, you're going to see that it, by mistake, decided to try to read one of the websites as a file. And you know that we just talked about how tools need to gracefully fail. This is a great example of this. The file content read to is not meant to read a website, but actually a file from your file system. So if you didn't plan for that, you would throw an exception and your execution would stop. But CrewAI automatically handles that so that it fails gracefully. So you can see that despite of it throwing an exception, it tells the agent that it got this error. So the agent kind of like now understands that it can directly access the external links using the read files content. So it's learning from the tool that it tried to use. So it then go back into search the internet to try to find more information about deep learning AI. So if you're building your own thing, or depending on your choices of framework, you might notice that if your tool finds an exception, the decision there is to let that exception actually blow up. And when that exception blow up, it stops the execution of your agent. So that means that hours that was completed so far is gone, and your agent execution stops, so you can't move forward. That means that you would then need to add an extra layer so that you can treat for that. Either kind of like kick off your agent from the scratch or do something else with that error. So for Crew, it was a conscious decision early on that we would prevent exceptions from stopping execution. But you might find other frameworks that choose it otherwise and choose to let exceptions actually stop executions. And that is the conscious choices that you can make. And if you're doing something from the scratch, because again, you don't need to be using a framework. You can be building these agents yourself. It's just going to be a lot more coding, but it's something that you need to be mindful of. How you want to handle exceptions when using tools is a big thing of agents. So you can see that, again, it finds a bunch of different researches and put together a deep learning AI company profile with a background, what are the key personnel, recent business developments, potential needs and engagement strategy, everything that we need to know about the company. Now, our next agent kicks in, the lead sales representative, where using the research that your agent did before, it's going to try to come up with a good way to engage with deep learning. So in here you can see that, again, it's doing some research online. Keep in mind that this is where some of that caching strategy that we talked about comes in. If this agent tries to do the same research or the same search online that another agent did, it's gonna hit a caching layer instead of strategy that we talked about comes in. If this agent tries to do the same research or the same search online that another agent did, it's gonna hit a caching layer instead of actually doing the search. So you're gonna be saving on rate limits and on the requests, and basically it's gonna just work faster. And here you can see that it come up with an email where we can send to Andrew. The subject is Enhance Deep Learning's AI Educational Impact with CrewAI Advanced Analytics. And then it goes on and explaining. And you can see that it even references the batch. The batch is actually a newsletter from Deep Learning AI. And we never told these agents anything about it. They learned about it automatically through the research that they made. So now we have an email that we could engage. And we actually have a few other options here. So you can see that it gives another option, now a little bit more focused on AI drive tools, and another one talking more about a partnership. So you can choose what email you want to use to actually engage with this company. This is such a great use case. Throughout our interactions with the community that has been building multi-agent systems, independently of what framework they are using, we realize that there's a few verticals that are very common, and sales is a big one. Because a lot of the sales process involves reporting, involves researching, involves engaging, and all that are things that can now be automated through agents. So it's going to be common for you going out there and talking with other people that are building agents to see that they're doing things in these verticals. And this is honestly a very interesting space in general. To integrate with your internal systems, to do some computational. It's a translation layer that allows your agents to communicate with existing programs that you might have. But in order for these tools to work properly, you need to make sure they're versatile, you need to make sure they're fault tolerant, and you need to make sure that they have a caching strategy. If you make sure that you're using those three qualities on all the tools that you use, you then have a system that is more reliable. So make sure to watch out for that when you're choosing what tools you're going to use or building your own tools. Keep in mind again that because we're using CrewAI, you can not only use the tools that CrewAI offers itself, but you can also use all the tools that LangChain offers. So you have a huge range of tools that you can start with. All right, we're gonna wrap this lesson here. You're doing amazing. Keep at it. You're gonna love our next lesson because you're gonna talk about even more interesting stuff that is gonna unlock more use cases. So I see. Welcome to our next lesson. And in this lesson, we're going to be talking about tasks. I'm super excited about this one. We talked about so many things already, and this is another great topic for us to dig into because in the end of the day, if you think about your agents, they are performing tasks. So tasks are a cornerstone on multiple agent systems as well. So when you talk about tasks, I want to bring back something that we talked a few lessons ago, the manager analogy. You might remember that we discussed that this manager mental framework to create agents, where you put yourself into a manager's shoes and you think about what would be the people that you would hire in order to do a series of tasks or the job that you're trying to accomplish. And then you kind of use that as a starting point to define what will be the roles, the goals, and the backstory of your agents. So you need to have a very good understanding of what is the goal that you're trying to accomplish, and you also need to have a very clear understanding of what is the process throughout to achieve this goal. So with that in mind, you're going to have a clear understanding of the people that you would hire, and those will be your agents. But now I want to build on top of this analogy. I want to expand this mental model to how you think about your tasks. Because whenever you hire someone to do something, you also cease to think about how you're going to delegate work to them. Especially if it's more of a junior person, you want to make sure that you're very explicit about what you expect that they do and what is the expected result. So I would say for you to build great agents, you should add that to your mental model as well. So once that you think about what are the people that you would hire to get this done, think about what processes and tasks I expect individuals on my team to do. And you can use that to create the tasks. And whenever you're creating a task, again, you need to have at least two things top of mind. One, a clear description of what is the task, and two, set a clear and concise expectation. Again, to go back to our analogy, let's think that you just hired a junior engineer to work on your team, and you're tasked with coaching this person. It's their first day on the job. You want to give them a specific task to work on. You want to explain that task very truthfully, and then you want to make sure that you say what you expect them to do. So CrewAI kind of forces you to think that way because CrewAI makes sure that it's mandatory for you to set at least two attributes on every task that you create, the description and the expected outcome. And that is used to build better internal prompts. But that also applies to any other framework out there. You will get better results if you go the extra mile on explaining what is a task and what you expect your agent to do. Other than that, there's a bunch of other things that you can set on the task. CrewAI offers a bunch of hyperparameters that you could use, like setting a context or setting a callback, or overriding the agent tools with specific task tools. Force human input, kind of like making sure that before the agent finishes the work, it stops and asks you how you feel about it so you can give further instructions. Also, we can talk about execution these tasks asynchronously or outputting the results as Pydantic objects or JSON objects, or even outputting them as a file, or running these tasks in parallel. So you can see how there's a bunch of options when we're talking about tasks in here. And you're going to need to take all that into account depending on how complex your multi-agent system is. Crew offer all these options, and you're going to find a bunch of them in other frameworks as well. Maybe not all of them, and maybe in a different shapes and forms. But in the end of the day, it's all about how you can set up your agents for success to perform their tasks super efficiently. So with that in mind, let's jump into code real quick. So in order to do it, I'm going to copy this code here. Keep in mind that we are also going to use Serper in this example. So you're going to need a SERP API key. that's going to be provided to you, but you can also find it going on their website, and they do offer free credits. So now that we set up the keys and the model that we're going to be using, let's go ahead and import our tools. We're going to be using two tools in this case, the Scrape Website tool and the SERPdev tool. So think about how those tools will fit together. The SERPdev tool will allow you to search the internet using Google and getting results back. And then the Scrape Website tool will allow your agents to go into those websites that it finds and getting their contents so that it can use that during the execution. So you can see here how planning out the tools goes a long way on how your agents are going to behave. All right, so let's create your first agents now. Let's first create a venue coordinator. And that kind of gives away what we're building here. The example for this lesson is a crew that is able to organize an event or a meetup for us. This first agent has one single goal: identify and book an appropriate venue. So giving an event circumstances and requirements, it's going to search the internet for venues that can support that and find these venues for us. Now we can create that agent. All right, so our next agent is going to be a logistic manager agent. So this agent makes sure to think through the logistics of the event. Now that the first agent already found a few options for the venue, it's going to think about how will this work out, and making sure that the venue is appropriated for us to do whatever we're trying to do with this conference or this meetup. So let's go ahead and create this agent as well. Our third agent is kind of like different. It's a marketing agent. It's supposed to work on top of the venue and the logistics and figure out how can we market this event, how we can market this meetup so that we can get as many people as possible showing up to this. So this agent's gonna try to be creative and thinking about the event that we're putting together and the venue and the location and bring all this together into something that we can use for marketing. So let's go ahead and create that agent as well. You can see here how this can be a pretty interesting too. We have a system now that is not only finding things about the event, but thinking about logistics and also thinking about marketing, everything in one go. And this would be extremely hard to pull it off with like conventional programming if you're not building an AI application. So now that we have these three agents, we're going to do something else, something differently that we haven't done yet. We're going to create a pydantic object that is going to hold our venue details. This is interesting because it's going to show off a new feature for tasks that we haven't discussed yet. So in here, you can see that we are importing the pydantic base model, and we're creating a class called venue details that it inherits from the base model. And we're saying that this venue details is going to have 4 different attributes: a name, an address, a capacity, and a booking status. The reason why we're creating this model is so that our agents can work with it and populate this model, create instances of this as they work. So this is a very interesting use case on how you can use agents to transfer the fuzzy outputs into actual strongly typed outputs that you can use on your regular code. So before we start creating our tasks, I want to spend a few seconds to talking about Pydantic. Pydantic is a library that has been getting a lot of attention. It allows you to create models and work with strong typed variables in a very easy way. So you can see here that instead of like what you would do with classic Python, where you would declare a class and then you would need to declare an init method, and in that method you would need to receive a bunch of arguments and then set a bunch of variables. It gets away from all of that and creates this syntactic sugar that allows you to create models in a very simple way. So now it's not only a class that you're creating, but you're creating a model, a resource that has attributes without having to go through the hassle of work with strong typed variables in a very easy way. So you can see here that instead of like what you would do with classic Python, where you would declare a class and then you would need to declare an init method, and in that method you would need to receive a bunch of arguments and then set a bunch of variables. It gets away from all of that and creates this synthetic sugar that allows you to create models in a very simple way. So now it's not only a class that you're creating, but you're creating a model, a resource that has attributes without having to go through the hassle of creating a niche method and setting them up individually. Pydantic is a huge library and goes way beyond that. So if you're curious about it, you can check it afterwards. But for the purpose of this lesson, we're going to be using that in order to transform some of the fuzzy outputs that we get from our agents into strongly typed outputs that we can use in code. All right, so let's get ahead and create our first task. So this task is pretty interesting. It's a task responsible to find a venue for our event. So you can see that it expects a few inputs in here. It expects an event city and it expects an event topic. And look on how we are using a few different attributes that we haven't used before. So in here you can see that we are saying that we want to output a JSON. And in order to output this JSON, we're passing our Pydantic object. So what is happening behind the scenes is that our agents are going to convert their fuzzy output into this very strong type model and then convert that into JSON. And then we are outputting that result into a file, a JSON file that we can actually use. So this is just to showcase some of these attributes that you get on the task class that you don't use very often, but are superpowers in certain cases. People use this a lot when they're trying to integrate agents into existing systems without doing it through APIs. So instead of having an API that is going to kick off your multi-agent system, if you want to have these agents within your code, this would be a great way to get an output out of them that you can already use on like a function or anything else. So now let's create our second task. Our second task is pretty interesting. It's a logistic task. This task is responsible for coordinating catering, the equipment for the event, and you can see that in this, it's expecting a few different variables, looking for what is the number of participants and what is the tentative date for this event to happen. You can also see us using a few different attributes in here. So you can see that we are using human input in here. This means that before this task is completed, the agent's going to stop and ask us, the operator, if we want to give an input, if we like the task result, or if we wanted to change anything with it. You can also see that we are doing a synchronous execution. So that means that this task is going to be executed in parallel with any other tasks that comes after that. So this is a very other good use case. Because if you think about it, this logistic task depends from the result, from the venue task, because the location is going to influence how you're going to coordinate the catering, the equipment, and everything else. But, as you're going to see in a second, it has nothing to do with our final task. So our final task is going to be our marketing task. It's the task responsible for creating the marketing campaign that will help us promote this event. So you can see in the description here that, again, we're talking about the event topic, the expected participants, and we want to report on all the marketing activities that we can do in order to promote this event. And you can see that this task is also allowed to execute in parallel. So what that means is that the first task, the task that selects the venue, is going to be executed by itself alone, as all the other tasks that we have seen so far. But after that, the logistic tasks and the marketing task in the results of the marketing task into a file. And in this case, is a markdown file. And because in the expected output, we're mentioning that we expect the result to be formatted as markdown, all this should work just fine. All right. With that, we created our 3 tasks. We're using a bunch of new attributes for the tasks. And you can see how you can leverage a lot of those for different use cases. In here, we're kind of like forcing ourselves to use some of these attributes just as a way to showcase how useful they might be in the real world. But you're probably already thinking about all the use cases that you can support thanks to some of these attributes that CrewAI brings into the table. So now that we have our tasks, let's make sure that we create our crew. And creating the crew is pretty straightforward. It's the same thing that we have done so far. We have a set of agents, a set of tasks, we set the verbose mode to true, and everything is ready. And we can now kick it off. So let's keep in mind that there's a bunch of variables that we use throughout the tasks and the agents that needs to be interpolated. So let's start by setting those up. So this is the event that we are organizing. It's a tech innovation conference, trying to gather tech innovators. It's going to happen in San Francisco. It has a date. We expect to have 500 people, and we have a $20,000 budget on it. We would love to have a conference hall that we could use for this. So these are all the inputs that this crew needs in order to do its research and actually fulfill its tasks. So let's kick it off and see how that goes. So from the get-go, you can see that the venue coordinator kicks things off, and it starts by trying to find a venue in San Francisco, because that's where we mentioned that we want this conference to happen, that meet the criteria for making a tech innovation conference. So in order to find that, you can see that it decides to search the internet. So it searched for tech conference venues in San Francisco. So it finds a bunch of results, as you can see in here. And then it decides to scrape one of these results. Among the results, it found tagvenue.com, specifically mentioning listening conference venues for rent. So it decides that it's a good call to kind of scrape that content. And here you can see the whole content that was scraped from that website. It's quite large, but now it's ready to give its final answer. The detailed content from the tag venue website helped it to kind of understand what are the options. So the selected venues have different sizes and types, and wants us to say, what is your feedback if we agree that for a large conference like this, it should go for the main hall at Trellis or the second floor at Dogpatch Studios? I'm going to keep it simple, and I'm going to say, yeah, I like these options. So now that I gave it the input, it's going to move on from that and going to keep executing the code. So if we look at what happens after this, it's going to pass on to the next agent that is now going to figure it out how to come up with not only the catering, but also the marketing from this. So you can see the final answer in here now that it took into account what we said. And look how cool is that? The output from our task is now a valid JSON. It's not text any longer. So you can see how our Pydantic output there is working its charm. We could use this to integrate with anything else. We could save this into a database. We could save this into a file. There's just so many options here. The ability to convert like agents output into regular objects that we know in programming, it's super helpful and allow us to bridge the gap between AI applications and regular applications. And you can see that even though this is JSON, this is being sent as JSON to our next agent, the logistic manager, to try to coordinating catering and equipment for that. So you can see that this agent now kicks off together with our new agents. So you can see there's two crew agent executor running here. We told that the last two tasks could be executed in parallel, asynchronously. So while we have one agent kind of looking into the catering, the other one is looking into how to promote this and what would marketing look like for a conference like this. So again, they're both searching the internet and trying to come up with everything that they need. All right, let's skip to the end and see what we end up with. So now let's look at some of the outputs of these agents. As they are wrapping up their work and coming up with their final answer, we can actually look at some of the files that got generated during the execution. First of all, you might remember that we asked the venue details to be outputted as JSON and written in a JSON file. So this is the JSON file. This is the name of the place, this is the address, this is the capacity, and it seems to be available for renting. And now we can also look at what the marketing strategy could be, because it also got written down in here. So in here we can see that is a fully fledged marketing campaign, thinking about the digital marketing, the content marketing, the partnership, the networking, the on-site, the tools, and even doing some budget allocation and how we could use our budget to actually market this.
So think about how amazing it is. You basically create a multi-agent system that is capable of not only finding like a good venue and figuring out how to organize things and bring the equipment and everything, but also capable of thinking about a marketing strategy and plan it out for you so that you can act on it. This is just the tip of the iceberg on what you can achieve with multiple agent systems, and a great use case and example on how these agents can be deployed outside in the world and not only in